Hello judges, we are Oxyguard team from MTS Negeri 14 Jakarta Timur. I am Rahma Kamila Idris.
Hello, judges. My name is Anissa Naila Aziza.
Hello, judges. My name is Altaf Tekuni Anji.
And I am Adam Abdulaziz.
Judges, Indonesia is one of the countries that is rich in horticultural products such as vegetables and also fruits. Vegetables and fruits have very vitamins that is super good for our body. However, in Indonesia, it is difficult to have fresh vegetables and fruits delivered to us every single day. Therefore, we, Team Oxyguard Innovators, have been trying to make a robot that can extend the freshness of both fruits and vegetables.
So, this technology is well needed, considering the fact that horticultural commodities has various weaknesses. One of them, their short shelf life. And also, if we don't handle this really well and they have unsanitary conditions, it will lead to rapid deterioration. That is why fresh handling technology is needed not only to maintain quality, but also for a longer period. This technology can help farmers and group collectors for improving their crops and vegetables and foods.
The formulation of the problem is how to design and build a cooling machine control system and controlled atmosphere storage for horticultural products based on Arduino Uno. Based on the stated problem formulation, the objective of the research is to design and build a cooling machine control system and controlled atmosphere storage for horticultural products using Arduino as the control system.
Benefit of research. Practical benefit to create an efficient in the form of a cooling and storage control system based on Arduino Uno. To expand knowledge and understanding related to control, serving as input for theoretical knowledge and free practice. To contribute to the development of remote control system. Theoretical benefit. Provide a foundation for other rights to conduct similar research aimed at improving industrial automation using microcontroller, particularly Arduino. Okay. Relevant research. The study by Bahram Shah titled Automatic Monitoring and Control Atmosphere System using Arduino on tropical fruit container integrated with IoT. The research by Widyaningrum titled Design of Controls and Monitoring System for Condition and Controls Atmosphere Storage based on Arduino. The study by Nedita titled Development of a Control Ventilation Box for Modify Atmosphere Storage of Fresh Produce.
Judges, here the system. Well, system is an arrangement of several parts with certain limitations that could work together to produce an output from the given inputs. In here, we use a microcontroller called the ESP32. The ESP32 Dev Kit is a microcontroller produced by Espressive and is an advancement of the ESP8266. Why do we use the ESP32? It is because this microcontroller has an integrated Wi-Fi module, making it suitable for developing the Internet of Things applications. The ESP32 also features a sufficiently fast processor speed for up to 160 to 240 megahertz. The software we use in this project is called Arduino IDE. Arduino IDE is a software used for writing programs, compiling them into binary codes, and then uploading them to the microcontroller memory on Arduino. To monitor the amount of oxygen and nitrogen in this robot, we can use the Blink application. Blink is a server service used to support the Internet of Things project. The server service offers a mobile user environment friendly for both Android and iOS. The Blink application, which supports Internet of Things or IoT, can be downloaded from both Google Play and also App Store. Blink is one of the applications that supports various hardware for IoT project, and there are three main components on Blink. Number one is called Blink Apps, number two, Blink Server, and the last one is called Blink Library.
The procedure for designing the tool. An integrated control system begins with developing the concept for the ESP32 microcontroller, designing the device, and designing components such as schematics. Next, a program is created in the Arduino IDE to process the input and output. This is followed by testing out the program, installing the microcontroller, system testing, and rechecking and making corrections as needed.
All right. From this, the development of the integrated control system begins with creating a concept using microcontroller. Subsequently, the device is designed by determining its inputs and outputs, programming in Arduino IDE, testing the program, installing the microcontroller, and testing the created system. Then after that, we can do rechecks if it doesn't function properly.
Well, based on the conclusions and also the design made for the development of the integrated control system with cooling and storage in a controlled environment, we have made one suggestions useful that could be useful in future writings for future writings. Perhaps in the future, we can add sensors for ozone level detection.
I think that is it for us. If there's anything wrong that we've done, we ask forgiveness for anything. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you Oxyguard Innovators ya. Okay, wow, very good presentation. Yeah, I really like with your emotion gesture. Yeah, how you present very well is very good. Yeah, and I admire you are in junior high school. You really have the courage. Yeah, to join the competition against the very senior. Yeah, wow, very good. Yeah, and and I can see this is a very good presentation also. Yeah, because. You able to provide the innovative work that you work and then this is my question for you first what challenge did you encounter while integrating the ESP32 microcontroller and how did you address them? Thank you.
Thank you, sir, for the question. So, we're still in junior high school, so we don't really know about engineering, right? So, we didn't learn, when creating this tool, we didn't know anything. So, we just tried adding nitrogen, something, then we tried opening YouTube, but that didn't work. So, we tried learning things, and then it took a while to learn that we should use oxygen, we should metabolic patterns with oxygen and carbon dioxide. It was a real challenge for us.
And how you can address them? Yeah, how you can solve your problem? Yeah.
We had lots of help, considering the fact that we don't have any background into engineering.
The teachers and my parents, also our parents, also help with a lot of things, including like perhaps how many amount of oxygen and nitrogen we need to have in the storage to keep the vegetables and fruits fresh, and how do we apply the kinds of output and how do we coding it, and well, there's a lot of things, and we really did not do it by ourselves fully. There is a lot of help from a lot of people also.
Okay.
Yeah, that's all.
My last question from me, yeah, before another judge. What is your next plan after this? Uh, do you will improve your system or doing some another project or what?
Yes, we will improve this projects based on the suggestions. Well, maybe in the future we will some sensors for ozone level detection, and maybe we will make other innovations, just like our name, Oxyguard Innovators. Thank you, Judge.
Okay, thank you.
Yeah. Hello. Yeah, same with Pak Matius. I can sense your spirits here, and uh, may I know how many times you already have joined like this kind of? Is this your first time?
Well, it's different for the four of us.
Okay. Yeah. Okay. Actually, your research also interesting because the idea is valid, yeah, and we need that kind of solution because all the products that deliver to the market need to be fresh, yeah, and also the thing is we need maybe to design the full ecosystem, yeah, rather than one independent system to be able to achieve to that goal, and that's why do you ever, when you work out on this research, have you ever think what is the real application when you install all the system, all the hardware, the software in the, let's say, in the market? Uh, have you ever tried to image the situation there, where to put all the, the
Put this
devices and yes.
project in the market. Uh, s- so this is like for farmers and like products like that. So
Okay, so judges, uh, a picture of it. This is actually a storage, more like a refrigerator kind of thing. So perhaps in the market they can use a, well, we use a styrofoam kind of base, and we will put the hardware and then in the storage and all of the other stuff. So when we project on the in the market, on the real life market, we actually just imagine them using the same kind of styrofoam, because carrying a refrigerator everywhere is heavy and all. But perhaps they can use a cooler also. Thank you, judges.
Okay. You want to add? To add the explanation? No? No, okay. Yeah, also this is my suggestion, yeah, because the system can only be applied when the economical value is achieved as well. So for the next, we recommend you also to start to think about the calculation in the economic feasibility, like because of the this kind of the horticultural product is not to, let's say, the value, the vegetables how much, the fruit how much, yeah. So compared to the all the costs when you do the research and also to establish everything inside is need to be calculated properly, yeah. And also my last question, yeah. Do you know the? Have you ever see the cold storage trucks in the road? Have you ever see?
Yes, we have.
Okay. Do you think the system will be already there or can be installed there or what?
All right. So the thing, refrigerators that's inside the trucks is like putting nitrogen right inside it. So then it's cool. But in our tool, we use sensors to maintain the quality. So we know when it's too much nitrogen or there's too much oxygen. And the trucks doesn't really know that, right? So this can be implemented to trucks too and distributed to other places.
Okay. Thank you for explanation.
Thank you so much for this, to Mr.
I hand it
Berry.
over to Mr.
Yeah, very good discussion. Yeah, I have some more question for you guys. Okay, first, can you describe the role of each one of you during the research?
Okay, so in here, myself, Zizi, uh, I was, apa ya? Well, I am. Mana ini? I was told to search how many amount of this about the ESP32, about what it is and what, and then what is the difference between this SP 682 66, and um, then I need to search what it is, what it's for, what's the use, and I was so search about an application that can be used for this project, and then that's when I found Blink, which is very useful. Mm.
All right. So I'm not in the background. I'm actually the back guy that's working for this system. Where's yours? Yes. So since I was the only one that could learn, I knew what this was. I was the one that helped her with the relays, and in the last minute, I still helped to teach her that what these are actually that. I was not in the background at all. He actually was. He helped for the relevant research.
So, what is your role in this research?
Yeah. Uh,
He tried finding all of this and all of the
I think I want to hear from him. Okay, it's okay. Just try.
wait, I can.
You can answer in bahasa Indonesia. Okay, please. Apa peranmu? Okay. Pakai microphone. Okay.
I was told I was told to write the formulation of the problem and the research objectives, and I was told to write the procedure, for, which is I have no idea, but I just help him write this procedure in a text, and I tried researching it, and yeah, I learned a lot of things from him.
the last chapter. Yeah.
Yes.
So who took the part to recombine each of the components?
I'm sorry, pardon?
So who was the engineer?
The engineer was Altaf,
Okay.
and we were, yeah, helped by
Okay.
the teacher, and the others were researching, making the text, and some other kind of stuff.
Okay. It's very difficult question. Yeah.
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 It's not like difficult, but like I can't like yeah get the words together.
Actually, I want to know: is it a teamwork or is it is just somebody work? So, yeah,
Well, this is a teamwork, of
teamwork.
course.
Yeah. Okay.
We act as people's help, not with teamwork, because they help us from the start to the end. We just told what we want, and they said you should use this and this and this, and then helped me check the code I created. I did not know how to implement the LCD I2C. It was so hard for me because the coding was right, but I had to buy lots of LCDs. One didn't work. One the light just turned on. What is this? I helped him and he helped me.
Yeah. Yeah. Okay. I think it is a very honest answer. Yeah. Okay. So let me check another thing. Yeah. Have you analyzed other or another tools beside Arduino?
Again, we are still in junior school, so perhaps Altaf have been doing a lot of research about this kind of stuff, like the robotic stuff. But we, as three, are told to use Arduino because it's like the easiest thing to code and all. But
We don't use the board Arduino. We just use the Arduino IDE. But the board we're using is ESP32.
Yes. Okay. Why did I ask about this question? Because I like you guys. Yeah. You have a very talented perspective in my opinion. For the next research, we suggest that you try to understand why do we need Arduino? Why don't we use Python, for example? Yeah, you need to understand that before you conduct another research. Yeah. Okay. So my last question is, what is your most obstacle during this research? Only one, the most main problem.
laziness. My laziness.
When writing the proposal in a Word, Word, yeah, the format Word, I was having difficulties with it. I was like, I don't know how to what font is it, blah, 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 that kind of stuff, and yeah, that was my challenge.
Can we like say one
Yeah.
each person? So I think my most difficulties is not going to lie. I think it's my laziness. It's hard to fight it. My job is only to search and like do research and combining them. Also shorten it, so it's not as hard as his. I need to fight my own laziness, and that is hard. That's my problem, my only problem.
Me, maybe I did buy a lot of these things. There were ones that didn't work that I said I buy so many LCDs just for it to not work. But actually, the main problem of me is the code. I'm usually with Python, but now with C++, yeah, I had to do lots of documentations.
maybe apa ya?
Apa kesulitan yang kamu hadapi selama bikin research ini? Di bagianmu sendiri ya, dapat tugas kan ya? Ya, apa kesulitannya? Oke, sulit cari informasi gitu ya. Oke. Yeah, I think that's all from me. Do you have any question?
Ya, ya pertama dengan kalian hadir di sini saja itu sudah menunjukkan keberanian kalian, ya. Dan itu sudah sangat dihargai, ya. Jadi orang yang berani itu bukan orang yang nggak punya rasa takut. Orang yang punya rasa takut tapi berani maju, nah itu baru namanya berani. Kalau dia nggak punya rasa takut, lalu kemudian dia maju, ya memang nggak punya rasa takut kok. Ya, tapi kalian walaupun takut, tapi tetap mau coba maju, itu namanya orang berani. Ya, dan apalagi tadi saya lihat ya, begitu banyak kesulitan yang kamu hadapi, banyak yang nggak ngerti, tapi yakin gitu ya, jalanin aja dulu. Ya, namanya belajar seperti itu. Ya, belajar itu nggak orang langsung tahu, nggak ada ya orang yang langsung tahu, tapi pengen tahu, ya ingin tahu. Nah itulah yang membedakan kenapa seseorang akhirnya bisa maju atau tidak. Ya jadi tolong semangatnya dipertahankan ya, karena kalian sudah memulai dengan sangat baik ya. Saya ingat saya seumuran kalian umur SMP nggak ada nih begini-begini ya, gitu. Tapi kalian sedini mungkin sudah melakukan hal yang seperti ini udah luar biasa sekali. Ya kalau dari saya tambahnya itu aja sih. Thank you.
Ya, kalian harus ingat apa yang disampaikan Pak Matius tadi ya. Jadi intinya gini, kalau kalian bisa tetap menjaga semangat seperti ini sampai nanti ya, sampai kapanpun, akan banyak beasiswa nungguin kalian nanti. Gitu ya Pak ya? Gitu, oke. Ya dari kami mungkin cukup ya Pak ya. Jadi terima kasih sekali lagi, kita kasih tepuk tangan buat grup ini. Yuk. Ya, silakan saya kembalikan ke panitia.
Terima kasih ya. Terima kasih.
Hai.
Can use the microphone. Oh, yeah.
Check. Ladies and gentlemen, since the COVID pandemic in 2019, electricity consumption in Indonesia has been surged significantly due to the increased demand for online interaction and online activity, such as studying, working, and also entertainment. In 2021, from the data of Ministry of Energy in Indonesia, they said that the electricity consumption in Indonesia has surged to 1,109 kilowatt hour per capita, which will increase significantly time after time.
But as consumption grows, most of the energy, renewable sources, and gas, the balance between the energy we produce and we consume is an issue. However, we may have found a solution: ferrofluid.
Before we get more into the details, let us introduce ourselves. People, we are Team Ferrofluid, Team Ferrotech from SMA Kristen Petra II. My name is Yeskel, and this is my partner.
Ms. Marvino, let's get right into it. So as we mentioned before, Indonesia's electrical consumption has significantly increased. Most of the energy comes from non-renewable sources, which could deplete over time and causes carbon emissions. So we need to look at other alternatives that are renewable, sustainable, and could meet up with the demand, which is ferrofluid. Ferrofluid can potentially convert mechanical vibrations, such as winds or any other activities, into electrical energy. So we don't need to rely on fossil fuels anymore.
Okay, now let's talk more about the ferrofluid. So what is ferrofluid? Ferrofluid are smart-like materials that behave like liquids, but they can be influenced by electromagnetic fields. So the particle have magnetic, they can act like magnet. So the particles will be aligned along the lines of the magnetic fields, which can create a magnetic flux. This magnetic flux can be used for energy harvesting. They can generate electrical energy when exposed to vibrations such as from wind, water, even from our activity. Now, the key challenge to make the ferrofluid is agglomeration. So what is agglomeration exactly? Agglomeration is when particles clump up together, forming a bigger particle called secondary particle. This may reduce the performance of the ferrofluid that we have created. Let me take on how we synthesize the copper ferrite ferrofluid. First, we took iron sand from the Sina beach in Tulung Aku that we carefully wash and we carefully dried to remove any impurities. After that, we separate the iron powder using magnetic separation. Now, this part is very important because we need to make sure that what we do after this is we only work with the iron powder and not with any compound else. Then we mix the iron powder with hydrochloric acid, creating iron 2 chloride and iron 3 chloride solution in return, which we react with copper 2 chloride to add the copper ions inside the nanoparticle structure, which we use oleic acid and also dimethyl sulfoxide as a surfactant to keep the nanoparticle and prevent it from doing agglomeration. And finally, we disperse the nanoparticle in sunflower oil to make it fluid-like and it can be more flexible.
We use XRD, X-ray diffraction, to confirm its sizes and structure. As you can see on the graph right here, the peak on the graph on our experimental data match with the model data CSD code database 000743, which is what we aim for. And the crystal size of 10.2 nanometers, which is ideal because smaller nanoparticles reacts better with magnetic fields, so it could have a potential result from converting mechanical vibrations into electrical energy. The results obtained indicate that coating using oleic acid has proven to be effective in controlling the particle size. As you can see, this picture is called cubic inverse spinel structure, which has two sides, octahedral and tetragonal. On the tetragonal side has half the iron ions, and the octahedral side has and all of the copper ions. The way these ions are arranged determines how the material reacts with magnetic fields. So ultimately, how it could convert mechanical vibrations into electrical energy.
Okay, so now let me explain about the nanoparticle morphology. So what's shown in the picture here is the nanoparticle was coated with the surfactant. As you can see, there's a lot of dark parts in this nanoparticle, which is the secondary particle or the particle that agglomerate together. So as you can see from the particle distribution reach 25.1 nanometers. This is pretty big and can reduce the performance of our ferrofluid. But agglomeration is expected because this is a nanoparticle because of the van der Waals force that exists because of the high surface area and also the volume. But we can prevent this happening, as I said, with DMSO as the surfactants. Now, this is the analysis using the FTIR scan. The FTIR scan is used to determine the presence of all ferrofluid components. It's divided into three components, which is filler, surfactants, and dispersant. The copper ferrite, or the filler, is contemplated in wave number 483 per centimeter, and it represents the metal oxide bond. The sulfur bond, or the SO bond, indicate the existence of the MSO, and also there's the biocompatible surfactant, which is oleic acid, in the wave number of 1,673 per centimeter, and also 2,694 per centimeter. And lastly, the sunflower oil is detected in 3,545 per centimeters. Now, this is the electrical performance of our fluid. We have three samples, one with 1 milliliters dimethyl sulfoxide, second with 2 milliliters dimethyl sulfoxide, and third with 3 milliliters dimethyl sulfoxide. As you can see, the one with 3 milliliters dimethyl sulfoxide gives the biggest amount of electrical current, which is 13.1 microampere. Now, this may look small, but since this is only a lab experiment, this already shows the best performance of the ferrofluid, which indicate the better energy conversion efficiency with smaller, well-controlled nanoparticles using dimethyl sulfoxide and also the oleic acid as the surfactants.
So in conclusion, the copper ferrite ferrofluid combined with DMSO and oleic acid demonstrated its potential as an energy for Indonesia's electricity future. The system is effective in converting mechanical vibrations into electrical energy, making it very promising for our future generations. Now we can open the Q&A.
Okay, thank you, Team Ferrotech. This is a very innovative idea, yeah. I have never seen like this before. Yeah, and yeah, maybe you can explain how you generate the idea. Yeah, how do you know that the ferrofluid, yeah, using sunflower oil? Can you tell us the original idea here?
Okay, since the ferrofluid is based on copper and also iron, as you know, copper and iron uh, is great for magnetic fields, but copper is great for electromagnetic fields. Video from YouTube that shows that ferrofluid that is created without any metal that any metal for that dope in the ferrofluid is can do well with magnetic fields only. So as you can see, we dope the copper ions to make the it can connect better with electricity. So why we use oleic acid and coat the particles, the tiny particles in the ferrofluid. When the tiny particles are coated, they force the particle to separate because particle in the base have the property to agglomerate, like I said, together. So with oleic acid covering the covering the particle, it can prevent the particle from agglomerating together.
Okay, I mean that the story behind this, yeah. How you generate the idea? This is like an assignment from your teacher or what? So you start looking for YouTube. Can you tell us?
Uh,
So this idea came from me and my team YesScale. We first from YouTube about how we can produce clean energy, and we found that any other YouTube videos are very simple and very common to do so. But we found at one day we found this copper ferrite ferrofluid, which is not common for anyone to present. So that's why we want to research about this. And with the help of our teacher, Mr. Rossi, we could make this presentation together. And we're here now.
Wow, I really appreciate, yeah, that you find difficult challenge, yeah. Wow, it's good. Okay, my question is, what do you think about this technology? Could be applied in the real world energy solutions?
oh yes, very. As you can see, ferrofluid like other electricity source such as wind turbine or the water wheel. When wind turbine works, they create the vibration, right? And as I said earlier, the vibration comes from wind into electromagnetic fields. This ferrofluid, or we can also use like automatic vibration created. The ferrofluid can be more truly.
Okay, it's not for me. Next.
Okay. Yeah, we do really need this kind of technology or new invention for our Earth, which is a lot of try to search, yeah, and to I mean. Not so many people care about this, I think. So I'm happy that you're still young, still in early education, but already think for our Earth. Yeah? My first question is, what are the potential environmental impacts of exploring materials to reproduce ferrofluid on a large scale?
Pardon?
What are the potential environmental impact when we exploring these materials involved in the research, yeah, when we want to reproduce on a large scale?
So when we do this on a large scale, we don't really need to rely on fossil fuels anymore because one, fossil fuels cause carbon emissions and they depletes over time. So in a matter of time, we don't know when fossil fuels could run out and we could run out of energy anytime soon. So that's why we research about this ferrofluid so that we can when the energy depletes, the fossil fuels depletes, we could use this as an alternative.
Okay. The next question is, what is the cutting edge technology can help accelerate this research for use in the energy sector?
What kind of technology can
Cutting edge technology, not just a technology.
cutting edge?
Let's say like a AI or AR
Oh, I see.
or additive manufacturing or other technology that can accelerate your research.
Yeah. So with the use of current technology like advanced what? Advanced AR, we can do visualization of the structure of the ferrofluid. So as I said earlier, this ferrofluid is still we still need to boost the performance of this ferrofluid more, like because we are still humans and sometimes in what we create. With using AI, we can produce more specific and more high quality and also high quality performance of the ferrofluid. As you can see from this part, we can prevent the ferrofluid particle to agglomerate even from the start. We don't need to use oleic acid anymore. With the help of AI, we can learn and we can produce more ferrofluid using maybe other materials like cobalt or maybe other metals.
Okay, do you ever heard about the additive manufacturing?
I'm sorry, what?
Additive manufacturing.
No,
Haven't.
Sorry.
Okay. So when we want to implement or realize this production in a large scale, yeah, because this is the new invention. Let's say we find a way to realize and need to, to use it in the real energy sector. We have to produce it in a large scale, right?
Yes.
So we need also the new technology in manufacturing. Maybe you ever heard, now we can print the metal, not the plastic. You ever heard? Yeah, maybe that kind of technology can help you to, you know, to to make it faster. Yeah, because like we all agree here that our Earth is not fine, and we need this as soon as possible.
Yes.
Even maybe we need it yesterday. So you can our suggestion, you can also to learn about the cutting edge technology that I said, yeah. Yeah, to combine this all together to faster all the research, yeah. Okay, this question is what forms of applications can be derived from the result of this research for future development? When you, let's say the research is success, then we want to produce, then what is the application, the real application? If we say the renewable energy, we have the, the wind, all the solar panel, or for this, please explain.
Okay, so to for the application of the ferrofluid itself, it's most likely a vibration-based energy producer. So we can make a mechanism. As I know, it's from oscillation production. so that this technology can that can make the ferrofluid produce fields. Then this electromagnetic fields will later be harvested using the energy harvesting technology, like that.
Okay. You want to add, please?
This method. Yeah, that's the method. That's the creation method. Oh, no. Creation method. That's creation method, not how we use it. Okay. No, we don't need to add.
Okay. Enough for me. Thank you.
Okay, thank you.
Okay, it is very interesting research. So I wonder, have you ever calculated the economic aspect of ferrofluids? Because I think to produce high quality ferrofluids in large amount is very expensive. Yeah. So have you ever considered about the economic aspect?
Okay, well,
So in our research, we use co-precipitation method, which is eco-friendly, economic, simple to use. So maybe in a larger scale, we can also use the same method in order to be economic.
Yes. Let me rephrase the question. Have you ever calculated the economic aspect? Not consider, but the calculated.
to be honest about the calculation of economic methods, we haven't really got deep into that calculation because what is in our mind for is still on how we have the idea to have a new renewable energy first, but we still haven't got into the calculation of the economics.
Okay, so you haven't calculated
Yeah.
the economic aspect. What about the environmental aspect? Because ferrofluid can be difficult to dispose properly. Yeah. Have you ever considered about that?
Well, since ferrofluid itself have a lifelong of 10 to 12 years, we only things to like make this ferrofluid long time, like 10 to 12 years. But after that, we may wonder what will we do to this ferrofluid because it's expired, right? Like, what do we do to this? Why just don't we modify it more? Why don't we turn it into something um, more useful to the electrical energy, or maybe more something useful to environment? So as you know, ferrofluid after it expired, it becomes it does not become fluid. We just use all of that ferrofluid, some new technology, like for example, we can use it to code machine to code cars so that it have to code cable for better.
Okay, so this is another issue that you need to comprehend, yeah, before suggesting somebody or some country to utilize this kind of research. First, the economic aspect and the environmental aspect for this, because the magnetic component of the ferrofluid, you know, the magnetic component is somewhat tend to be clumped. You know, clumped, menggumpal. Yeah. So that's the issue. Yeah. Okay. Okay, Pak. Back to you.
Yeah, thank you once again for your participation and presentation. Kembalikan ke Pak Didi.
Oh yeah. One more thing. I read your paper. You mentioned figure 4 twice. Yeah, you need to check. Yeah.
Okay, okay.
Okay. Because the last paragraph you stated that based on figure 5, I could not find the figure 5. Okay.
Oh, okay, okay.
Okay. Yeah. Okay.
Okay, thank
Okay,
you.
thank you, thank you.
Yeah. Okay, so yeah. Okay.
Oh. Oh. Waduh, teliti juga, Pak.
Tes, tes, tes satu dua, tes satu dua, tes.
Hello? Hello? Imagine a world where approximately 3.6 million people die annually due to undrinkable water. This is our world we live in, and the number may soon rise even more. 30 By 2030, solve this. We plan to solve this issue with our solution. So our team consists of Sarah Elena Suslistio. She's our project manager and manages the project from development to completion. And Tiffany Annabelle Blessing, she's our communications manager and manages both internal and external communications with the assurance of clear messaging across the team. And me, Vince Kareen, creative director. I develop concepts that will result in engaging content throughout the project.
So the start of this presentation, clean water and sanitation are all obviously primary needs for human health, and most people in different parts and areas of the world suffer due to serious water quality problems. This can be improved though through innovation to help with SDG number 6, clean water and sanitation for all. In this presentation, our group will describe and outline a compact water purification system that can filter, boil, and make water safe to drink using combined systems and also by using UV light. Automating these steps for supply areas with clean water of limited resources, offering a reliable way to tackle the scarcity of water.
The problem. More than 80% of water waste around the world goes back to the environment without it being treated, linked to hundreds or even thousands of children under the age of 5 dying every single day from diarrhea caused by dirty water. To solve this problem, we want to create a system that can clean and filter this dirty water, making it safe to drink, bathe in, and use for cleaning. Our solution will use advanced filters and disinfecting methods to ensure everyone has access to clean water and helping reduce diseases and improve health, especially for kids. The problem. According to UNICEF, the deaths of dirty or unsafe water rates are approximately 1,000 children under the age of 5 every single day, caused by diseases caused by water pollution, lack of sanitation facilities, and poor hygiene. The annual deaths every single year, 85,700 children under the age of 15 die from diarrheal diseases linked to unsafe water, sanitation, and hygiene. Wash facilities, and the total of the annual deaths are around 72,000 under the age of 5 die annually from similar illnesses linked to wash access problems, compared to 3,400 from war-related violence.
You can see our solution is special filters and disinfectants, harmful germs and chemicals that are. We'll use such things as charcoal, ultraviolet light, and chlorine to clean and purify the water from. This system will be easy to use and will work in cities and small villages. Water available to all the kids. We can most prevent the sickness all over the world.
Our idea is basically boiling includes boiling, filtration, and UV purification. Boiling will kill harmful microorganisms such as bacteria and viruses, while filtration removes contaminants such as dirt, debris, and some chemicals. UV purification involves the destruction or deactivation of microorganisms using ultraviolet light that further ensures the cleanliness of the water. In summary, the methods together should take care of the water and make sure it is safe for you to drink, clean, and bathe in. It's not entirely available in an area.
So the advantages to this idea would be starting off is that it is effective against microorganisms, killing bacteria and viruses. And to boil the water, it's simple and low cost, requiring only a heat source. It can remove contaminants such as dirt, debris, and some other chemicals. And also having long-term use can be used repeatedly. And then for the filtration part system, it has a variety of options available in different forms and complexities. Lastly, for the UV purification part, is effective against microorganisms, being able to destroy or deactivate microorganisms. It is also energy efficient, requiring minimal maintenance and energy. And it also has a quick and fast purification process. But of course, there's some disadvantages. Start off again. To boil the water takes up some energy, which is not feasible or ideal in some areas with a limited power supply. And then filtration systems do require like regular maintenance and also periodic filter replacements. So, which adds to the overall cost, and filtration so almost always need constant upgrading or replacement. And then lastly, for the UV purification part, these systems are usually more costly upfront and than other methods, especially those of higher capacity.
So why are we doing this? Both adults and kids under the age of 18 have died or gotten sick by simply drinking dirty water. Our body is 78% water, and these people have no other option or die from dehydration. Our team believes that with the help of our creation, deaths should significantly lower or give people at least proper hygiene.
So as you can see with these statistics, study like pollution kills 8.3 million people annually. That's per year from toxic water. And here, this is public concern about pollution. of drinking water in the United States from 1990 to 2024. So here's our cited sources, and thank you.
Yeah, okay. Thank you, Team Z. Yeah, I think you have a very interesting research, and addressing the issue of clean water needs is very important, yeah, because we really need, especially in Indonesia, in East Indonesia, they have many problems in there. Yeah. Okay. My first question is. You have two methods, yeah, between to against the microorganism, yeah. First, the boiling water, and after that, you also have the UV purification. This is an alternative method, or you use both boiling and UV.
So it's a step-by-step process. So we start with boiling, and then when it's the correct heat, so we can like filter it, and then once it's filtered, once it's filtered, we use UV light to kill all the smaller microorganisms.
Okay, because you said that this is the step by step, so it's mean. Okay, you want to add?
So basically, first the process will be like water will get filtered through the filter, and then it will be at the last to chemicals and germs. The boiling, there will be no more access the breeze from the filters, right? So then it will kill most of the bacteria, and then the uh, clear off harmful chemicals that might injure our body.
Okay. You said that after the filtration, you go to boiling, and after that, you go to the UV purification, right? Both boiling and UV purification for against the microorganism. This is a two-step process. So in terms of cost, is double the cost, right? So why you use these two methods? Why you don't just using one method? For example, only the UV purification.
Well, we want it to be as safe as possible because if it's only boiling, there's a chance that there's still some viruses that still live. So if we filter it, since it's water pollution, there's also some chemicals in the water. There's a chance. So if we boil it, we kill the microorganisms. But when we filter it, it also removes chemicals. And then once it removes chemicals, we can also filter it one more time.
Oh, okay. Okay. My next question is, how do you envision the system being implemented in remote areas? Yeah. Can you explain? Because in remote areas, for example, in East Indonesia, is very far. And how you think you envision this, put your system with a very limited resources? Can you explain?
Very limited resources, we can provide like how do you say that? We can provide like support from the donations that we receive, and then we can like go to those cities and actually build the system itself in the city village that does not have a lot of resource, so we can bring it from somewhere else, transport it.
Okay. Okay. Thank you. Enough for me. Next, just.
Okay. My first question is, what are the main groups of parameters that must be tested to determine if water is safe for drinking?
To determine if hello, determine if like water is safe for drinking is to see if like mainly to see the color of the water. If it's like clear, then yeah, you know. But then like you won't drink water that's like black, right? the next step is the pH level. If it's too high, water, and if there's any like contaminants maybe living in the water, so we'll, like test it either with a microscope or with boiling method that we've like mentioned before, and make sure like all those microorganisms will be like removed.
Okay. So we can assume we can grouping in three aspects. Yeah. Let's say one is microbiology, and then physically like you say that it must be clear. Yeah. And then the last one is chemically is safe. Yeah, to be drink. And then, in your view, what sensing technology could be used to test whether a water sample has an odor or not? Odor, yeah. Like smelly or...
Basically we'll select like special water, special like water from like sources not from like the river, and we'll put it in. That's not really efficient. It'll make it also dangerous for us to drink even though it's already filtered and everything. Water from like for example like the ocean, um or like places where that isn't too dirty but then like gives off that like safe environment to like drink in. Like without it, then it might have like the color of the water and like the smell of the water might be different to like what you expect, because like the sungai or
Okay,
like
actually my question is there any technology that can sensing whether the water have a smell or not? Do you know?
so basically we'll add like my bad.
So we didn't do any research on that since we were focusing mainly on the cleanliness of the water, of the quality of the water itself. But I think, if I'm not mistaken, I think there is a sensor that can sense the odor. If I'm not mistaken, I think there is.
Sorry, can you repeat again the last statement? I cannot hear.
I think there. I think there is a sensor for. So yeah. Hello.
Okay. Please repeat again.
So yeah, so we haven't really researched on if there is we didn't really focus on the smell of the water itself, since we figured it wasn't like the most important part. So
Yeah, actually, yeah, for your information, the technology is there, like vapor detection, yeah, for the like a device to sense whether the packets have drugs or explosive materials, yeah, but still very expensive, yeah. And there's please put in your consideration when you continue the research, yeah. And also the last one is since you mentioned you will put sorry, you will use the chlorine inside the water. Please confirm whether you will use the chlorine inside the water, you mix it, or you use chlorine for equipment maintenance or equipment cleaning or what? Please clarify.
Basically, we will use the chlorine in the water, and some chlorine is drinkable, and you can actually like consume some chlorine, but like not the one that's like used for pools, cleaning. We'll use it for the one that's like safe for like drinking and to purify the water like 100% without any microorganisms or like any other stuff.
Okay, thank you.
Okay, it is a very interesting presentation. But I wonder how do your proposed methods, you mentioned three, yeah? Boiling, etc. How do your proposed method ensure sustainability, especially in terms of energy consumption? Uh, as you know that boiling requires substantial energy.
Basically, what we're gonna do is limit the energy use in the boiling part, and for the UV light, we can specify like the energy, yeah, maximum energy. So like it won't use too much or it won't use too less to like make the water unsafe. So it will just be in the right amount of energy to be purified. And for the gas, for the boiling part, we can limit the gas use or like the energy use, because like we don't need like as a high heat, because we don't need like it to be like instant. It can be like, because it takes like 1 hour, because like it needs like the chlorine to set in and everything.
And then also using solar energy to like provide energy for the system, since solar energy is more sustainable compared to other how do I say, like energy providers like fuel or like gas.
Okay, you mentioned before you can control the usage by using what? AI or something?
So if I'm not mistaken, there's a device to like limit the energy use, like limit the energy use that's used here. So for example, these lights, there's like a special type of lights that has only like, for example, 25 watts, and it won't go over or under 25 watts. So then it can function like as properly as it's supposed to function.
Oh, okay. Oh, yeah, I still wonder about your one of your method, yeah, especially the water filtration system. Yeah, so what specific challenges do you foresee, yeah, with the long-term maintenance of the filtration system in the, for example, a remote area?
So probably like one of the biggest issues would be the overall cost, since it needs to be like replaced like periodically. So and there's also like lots of requirements for the replacements.
The other challenges that we might face during the process of like the filtration part is when in the remote areas, for example, like islands, because like Jakarta, like Indonesia has a lot of islands. The challenges is like we'll need to spend like a lot of money to just go there and then replace the filters every, let's say, 2 weeks. So then basically it will be a challenging process for us to go to these remote areas and change all the filters at like once.
Okay, thank you. I think your team needs to consider the economical aspect of what you are suggesting, yeah? Because I hope this suggestion is a long-term perspective, yeah? And then you need to calculate more about the economical value of it. Okay, thank you for the team.
Cukup ya, kita kembalikan ke panitia. Makasih.
Good afternoon to the honorable judges. First of all, we would like to thank the judges for giving us the opportunity to present. Introducing us from the Monyet Jawa Mandua Jakarta team, my name is Muhammad Abu Fadl Abbas as a team leader. Here we will present the results of our research entitled Oxybeat Healthcare Heart Rate Detector and Oximeter as a Solution for Remote Areas. So, access to healthcare in remote areas remain a critical issue, with over 30% of Indonesian population living in remote areas with 30% of populations in the Indonesian 30% of Indonesian living in areas difficult to reach by medical facility. This causes delays in getting medical help, which can worsen health problems. To address this, we have developed Oxybeat, an IoT-based system that can measure heart rate and blood oxygen level. This enables people in remote areas to monitor their own health using devices such as cell phones or laptops. The use of Oxybeat not only speeds up early detection of the problem, but also increases awareness about the importance of health problems, of self-health monitoring. Sorry. Yeah.
Formulation of the problem. First, how can we answer the Oxybeat is easy to use for everyone, including those without a medical or technology background. Second, how does Oxybeat water actually detect heart rate and the blood oxygen levels?
Research objective from Oxybeat is first to ensure the Oxybeat device is easy to use for everyone, including those without a medical or technology background. Second, to find out how the Oxybeat device works to accurately detect heart rate and blood oxygen levels. Next.
Now let's move on to the benefits. We divide the benefits into two sections, theoretical benefits and practical benefits. There are two theoretical benefits. The first is contribute to creating portable medical devices that can be used in remote areas, thereby facilitating access to health services. And second, formulate a theory about self-health monitoring that increases public awareness of health and prevent disease in themselves.
And for the practical benefit, Oxybeat allow people in remote areas to monitor their own health, so they doesn't have to go to a health facility. Second, residents in remote areas can detect heart and blood oxygen problems more quickly, so they can take preventive measures or seek medical help if necessary. And for health institution, so the resident in remote areas can check their own health. So the health institution are not too burdened by the visits that can be handled at home, such as checking heart rate and blood oxygen levels. This allows medical personnel to focus more on patients who need immediate treatment and patients with an emergency situations. Next.
The data collection method used in this study is the research and development R&D approach. This R&D method follows the ADDIE development model, which consists of 5 stages. First, analysis; second, design; third, development; fourth, implementation; and last, evaluation. So here is the overall component design of the Oxybeat. And here is how our tool system works that has been made in the form of a flowchart. Next.
Data collection tools. For the data collection tools, the hardware is ESP32, sensor mic D0102, power adapter LED, and for the software is Arduino IoT Code.
So And this is the MAX 30102 sensor testing for the BPM, where we look for the accuracy, where we look for the error value, so we know the level of accuracy. Because if this device is not accurate, it will be a big problem for people in remote areas. So you can see there is error value, and how do we get the error? How do we get the error value of this device? And this is error value equals theoretical value minus experimental value divided again by theoretical value times 100%. So how to get the percent of accuracy? The percent of accuracy equals 100% minus average of the error value equals 100 minus 8.2%. So the accuracy of the sensor testing BPM is 91.2%. And here is the sensor testing for the SPO2, where we again look for the error values so we know the level of accuracy. So we give it a 10 test and look for the error value so we know the level of accuracy. So that is the formula we've reviewed before. And the percent of accuracy is 100% minus 2.8% equals 97.2%.
Functional testing is performed to ensure that the tool operates correctly and safely. It involves evaluating features such as displaying BPM and SPO2 sensor values within Arduino IoT Cloud application. Additionally, we check system's ability to present these values in graphical form for clear visualization. This process helps us to identify any potential issues or areas that may require improvement, ensuring the tool is functioning optimally before it's ready for wider use.
So as we know, the functional testing, the object is the Arduino IoT Cloud application. So the results, we can call it the IoT application testing results.
The results of our functional testing show that the system successfully displays both BPM and SPO2 sensor values in the Arduino IoT Cloud application. Additionally, the system accurately presents the corresponding sensor value graphs, confirming that the tool functions as expanded. There we no significant issues identified during testing, and the tool is ready for further use.
In conclusion, the research resulted in a prototype IoT health system called OxyBeat, which is able to detect heart rate and blood oxygen level effectively. The test results showed that the MAX 30102 sensor used was quite accurate, with an accuracy rate of 91.8% for heart rate and 97.2% for oxygen. OxyBeat is designed to make it easier for people in remote areas to monitor their health without having to go to a health facility. In addition, this tool helps raise awareness about the importance of self-monitoring health so that people can take action more quickly when health problems occur.
About the suggestion, we can make OxyBeat is more focusing on energy efficiency. So we can add some like solar panel, so we don't use battery anymore. So we have demonstrated how OxyBeat utilizes advanced technology in monitoring health. So do you have any questions?
Yeah, thank you, Tim Monyet. And I really appreciate your research. You address the issue of the health for human being, and especially because you address to human area. Yeah, I think for we need to think about the human right. It is not just for the area
Yes.
mentioned too. My question is how this your system CBIT communicate to internet? What that you are using?
So we use the microcontroller ASP32 with the phone through the Arduino IoT Cloud application. So it will display the graphics and the values of the BPM and sensor and the SPO2 oxygen.
System connect to handphone?
To phone with the ESP32 to the Arduino IoT Cloud using IoT.
Connect to Arduino out, right?
Yeah.
In the
Mm-mm.
the connection from your
Mm-mm.
to internet in the cloud.
Yeah.
What you
The Wi-Fi from the ESP32 microcontroller. ESP32. Yes.
How about if the area they don't have the Wi-Fi connection?
Gimana ya? So the connection to the phone is show the graphics and the values, but we use LED. So if you cannot use the phone, you just can check on the device. So the phone used to show the graphics and values, and maybe save the data. Save the data maybe is the use of the phone. So, but if you want to see the SPO2 or the BPM values, you can check it on the device. They're lucky, so there is two options.
Okay, great. So, what do you think? Function. You can read the data from your device directly. Why you data to the internet?
So it can save data from before, so you can check the data maybe in many days. I mean, if we check on the Tuesday and we check again on the Sunday, we can check again on the Tuesday what data is. So it's to save data and for show the graphics. So maybe in this Tuesday it's low and in the Sunday it's high. So it shows the graphics.
I think you have to. This is my suggestion, yeah. You have to. Why you should save your data to the internet, yeah? Because maybe because if you just save the data for the internet, you can save the data directly to the internal memory in your. It doesn't need save data from the. That's
Yeah.
my.
Okay, sure.
Okay, I think that's all.
Yeah, thank you. First of all, I'm still curious about your answer. Why you? Because actually it's a valid question. I think, yeah. Why use the internet technology while you can store the data in the internal memory? Yeah. Do you have any other reason to do that?
The main reason is to save data, and if we can do that with another device, or maybe if we can write it in a paper, it's to show the graphics of the value, so we know, yeah, the graphics.
So if you have graphic, that means you can analyze.
Analyze, yes,
Okay.
analyze. We can analyze.
Okay, my first question is, what are the advantages of your research compared to existing wearable technology in the market? You know, like I'm using here, I have the sensor of the BPM and so on. What your technology advantages?
Apa perbedaannya, kelebihannya gitu daripada device-device yang lain? So it's more cheaper than the existing technology because our target is people in remote areas. So we have the prototype, but for the real devices, we made it more cheaper because our target in remote areas, and we know there is not much rich people in remote areas.
Is later. My because heart rhythm problems known as cardiac arrhythmia affect millions of people in Indonesia. Explain how the system in this research, how your research can detect the heart rhythm problem.
So we know there is some information if your BPM is low, that means you are sick. So this device, the real function of this device to speed up early detection. So if there is a problem, we can take preventive actions or preventive measure more quickly.
Yeah, actually, there is like a false positive result that can bring up to into your system. So, is there any way you can detect this is a false positive or not? You know, the heart rhythm problem sometimes is already there, like since birth already have a problem, but actually it's safe. Do you know what I mean?
I'm sorry, can you repeat the question? Can you repeat the question? Can you repeat? Can you repeat?
Yeah, in Indonesia, many people have these problems since birth already have. So like the kelainan. Yeah. So it's all it always the status and also the condition is from birth.
Will never change.
It's some doctors can say it's okay because already like that since birth. So how we can detect whether this is safe or not your system.
For the people who had that
Yes.
disease.
Yes, because it's many people have that in Indonesia. Millions people says.
Million people. Jadi ada kelainan penyakit yang udah kelainan dari lahir itu kan pasti terus utama terus.
If you haven't do that, it's okay. It can be your recommendation.
So that is our evaluation because our target is to detect heart rate and oxygen that can maybe change. So if there is some disease that maybe not change, then our device cannot do that. So
Yeah,
that's our evaluations.
That guy, let's say me, myself, I have that kind of conditions from birth. And I'm still alive and okay still now.
Okay.
If your system detect and say I'm sick, there's a problem, you know. You know what I mean?
Oh. So maybe there's an exception for that disease.
That's why you need to include in your
you need to might improve.
Understand,
improve,
right?
Improve, yeah. Improve and evaluation. Okay.
My last question is how do you determine and select the body part for flexing max 01, 02?
Sorry, can you repeat?
Where do you put the sensor in the body?
Oh, we're put in the in the up one. So this is the prototype.
Which part of the body you will put that? Thumbnail? Okay. Bahasa Indonesia nggak apa-apa. Okay, thank you.
Yeah, you can take a deep breath first, okay? Okay, just take it easy. Yeah, I have two very simple questions. You mentioned that Test. Okay, you mentioned that there are 10 test results.
Yeah.
Right? Yeah. Can you tell us more about the respondents? Because I couldn't find any information in your paper.
We test this device on one person 10 times. So if the result is different, then the accuracy won't be 100%. So we use the formula to find the real accuracy using the error value.
So is it correct?
So the accuracy for the BPM IPV is 91.8% and the SpO2 oxygen is 97.2%.
No, I meant it research. Is it correct to just involve one subject?
No, because there may be some changes. So if you do one experiment to one person, just one, it may be 97, and you just this is 97. But if you do the second, it will be 95. So there's some changes. We need to find the accuracy because it's not always be 100%.
So based on your answer, what is the lack of your paper? What is the limitation of your paper?
Kita kurangnya apa nih di ini? Can you repeat the question?
Yeah, basically, you cannot just rely one research to one sample only. Yeah, although you take 100 or 1,000.
Or we have to make many subjects like 2%,
yes,
3%,
okay,
4%.
Yeah? Okay.
Okay.
So second question is, you mentioned that your device will be cheaper, right? You just mentioned that before.
Yeah.
So how much does it cost when somebody asks you, about your device? Because there are a lot of cheap devices in the market, yeah. So have you calculated before?
Harga jual.
Let's pretend that the three of us is the future investors, yeah?
Yes.
So how much does it cost?
Ribu ya? Biar nggak usah. Hah? Jadi harga di bawah 100.000 ya. So we will sell it if we meant to sell it. We will sell it maybe below 100,000, maybe from like 50,000 to maybe 70,000. But we know that the people in remote areas, many people would not cannot buy it because they doesn't have money. So we will maybe actually need some assistance from maybe non-government or government organizations to help these remote areas. So and maybe some donations for people in remote areas for this device.
Okay, so this is not a business-minded project. Yeah.
Yes. Yeah.
Good. Yeah, that's good.
Yeah.
My last question: what is your next step based on this research?
My next step is to make this device connect directly to the health facility. So this doesn't have to go to health facility. The health facility know if there is a problem, and they are the one who will solve it. Maybe they will sending some ambulance to the remote areas, because if this is not directly connected to the health facility, still the people in remote areas have to go maybe far, maybe 30 kilometers to the health facility. So this device is to speed up early detection, but if it's connect, it will be more easier because they doesn't have to go far again to the facility. The facility is no, and we'll send some assistance or helps. Yeah.
Why you should connect to the internet? That is the answer.
Mm-mm. Yes. Yeah. Yeah.
For just storing the data,
Uh-uh.
not the data in the internet.
Yeah.
But you said in this your plan
Yes.
that you want to inform
Yeah.
the situation. Healthcare.
Mm-mm.
That's need the internet, right?
Because we've made this self health monitoring because we think about the signal problems in remote areas. Maybe we can use some like long range radio, maybe, or some long range communication because the signal in remote areas are not good. Yes.
That's why also I asked before about the connection.
The connection, yes. Yeah. Yes.
I think
Yeah.
we have the plan.
Yes.
It's already in your head.
Yes.
Lagi mungkin tegang gitu ya.
Yes, yes,
Okay.
yes, yes. Okay.
Very interesting. Thank you. That's all. Thank you.
Okay. Okay. The thank you. So. Yeah.
Break dulu.
Cek satu dua, cek satu, halo, cek satu dua, cek satu dua, cek. Cek satu. Oh, yang ini lancar. Tes satu dua, tes satu. Cek satu dua, cek satu.
As the world moved and shifted to a cleaner energy source from oil and coal to wind, water, and solar, we as Indonesians couldn't be left behind from the world. Good morning, Mr. Matthias, Mr. Marcus, and Mr. Subarjo as our judges. Let us introduce ourselves. My name is Raiden Immanuel Setiawan. Ansel. And we are from? We have chosen hydropower as our renewable energy source. Why? Hydropower is one of the most reliable and cost-effective energy source for the moment. It is used by a lot of country already, and even some country have used 100% of their power generating from hydropower. So in this presentation, we aim to see the capability of using hydropower generators in the canal networks of Indonesia. The first advantage is having almost no intermittency. That means the hydropower generator can run for 24 hours without much problem. The problem with having intermittency that it can cause unreliable, it become inconsistent and unreliable in a lot of situation. And the next is a low cost over a lifetime. That means, yes, it have a high initial cost in the beginning, but as times runs on, the energy generated from the hydropower plant will be a lot more than the initial cost. So it will become very good for the long run. So Hansel, what is the next two advantages?
The next advantage is due to our flexibility. According to IRENA stands for International Renewable Energy Agency, hydropower is the most flexible and renewable power generator all over the world because it can shut down and it can turn it on back anytime it wants. But we need to acknowledge that the responsiveness is depend on what turbine do you used. And the next thing is to do to our location. You know, right? Indonesia is maritime country that has tropical climate. That means we have a large amount of water area in this Indonesia. And the most important thing is Indonesia is a tropical country. That means the water cannot be frozen. And by that, we can produce a massive amount of energy, of power through water. What is the next thing, Raiden?
So, when there's good, there's always bad. What is the disadvantages of hydropower, Hansel?
The disadvantage is first, due to our safety. Because you can imagine, right, if someone fall into our power generator and that person cannot swim, that in the worst scenario, that person can drown, or in the worst scenario, that person will die. And the next disadvantage is due to our environmental effect. Why? Because we know, right, there is so much living organism, like such as fishes, plants, and small amoeba and stuff like that lives inside the water. With our high velocity of turbines, that can damage or even kill most of the living organism inside the water. What is the next thing, Raiden?
We have talked a lot about hydropower plants and the disadvantage and the advantages. So, let us show you our plan. Let us introduce you to
RRR, or most commonly known as run-of-the-river hydroelectric power plant, uses the run of the river, hence its name, to move the turbines and generate power. There are three main types of ROR. The first one is called a dam tow. A dam tow uses the whole river and puts turbine in the middle of it. So the run of the river could move the turbines and generate power. The second type is the diversion weir. The diversion weir diverts some of the flow of the river into a passage so it can be put into a power plant to produce energy. And then finally there is pondage. The pondage is a small reservoir of water usually behind a short dam. So the power will be generated from the power of gravity and also the run of the river. Now, for our main idea, we're going to use
the Siak Canal as a base, as it has a depth of 30 meters, although it's now 18 meters due to silting, and also a width of 96 meters. So we can put more turbines in it and thus generate more power. The first part, as you can see from our presentation here, is the trash rake. The trash rake will be there to catch any waste and any trash along the way, and also automatically collects it into a loading container, so the government can use it for maybe recycling or sort it out and use for whatever they want. The trash rake itself will use the electricity generated by the dam to operate. And then the second thing is we will put a pump house. Although a pump house could generate a little amount of power by retrofitting some small turbines underneath the pump house. Its main purpose is to prevent blockage, since if there's too much blockage, can cause flooding to the surrounding vicinities. And since we're going to build it on a open sewage canal, it could flood the cities and roads. That's why it is very important for the pump house to rush the water through to the other side, so it can not flood and be used for power. And then finally, there's the dam. The dam will probably be 80% of the sewage canal depth, so it can utilize as much gravity power as it can, especially since this is Siak River, and as I said, it is now 18 meters. You can actually dig up the silt to procure the original 30 meters, so there's more energy.
Okay, so a variety of problems can occur during the operation of the dam, most of which are entrapments, confined spaces, and slippery surfaces, which could lead to fatal injuries and even death. But most of these problems can be mitigated by just limiting access to the surrounding areas of the dam. But one major problem that can be major is the high water pressure. The high water pressure can lead to erosion to the metal surface of the water downstream. But we, as a team, have come up with a solution. What is that, you may ask? It is the hydraulic steering basin. The hydraulic steering basin comes in a variety of models, most of which is used to dissipate or reduce the high water pressure. It is placed at the edge of the spillway to reduce the water pressure. So, there is model type 1 to type 4. There is no type 5, but there is type 6. The key difference between all of the models is the cost, the complexity of the structure, and depends on the condition of which you want to use it in. The one that we're going to use is the type 2, which is fairly simple in design and fairly low on cost, but it's suitable for the dam that we are going to use.
We are not from the future, but our innovative ideas, our creation, will definitely lead us into a greater future. It is from us, SMAK Kalam Kudus Green Garden. We want to say sorry for our mistakes and mispronunciation. That's it from us, and we want to say thank you.
Wow. Wow, this is your and that you are creating using the hydropower. It's very important aspect for our environmental. Yeah, this is a green energy. Yeah. Advantage.
All right, thank you for the question, sir. To begin with, to answer the question for how the living animals uh, can be changed because of the build of the dam. Some dams could actually build spillways for like fish to actually go up to the water, so they can just act as if the dam is not there. Since most fish that live on the river or in the canal, they usually like to fight the flow of the river. That's why they're already conditionally they could be conditionally led through a spillway, so they can just went up it. Also, you could also use some turbines that could minimize the damage that some fish or some plants could go through, since most of the fish died due to pressure differences in the turbines. That's why if you just change the design of the turbine so it can be friendlier, you could also just they could pass on through safely, even if it's through the water turbines.
Tidak, ya. Uh, gitu like I or I project.
Thank you for the question, sir. With AI and IoT being very good at logical processing, we could use it to make very accurate, almost lifelike simulations, so we can reduce the cost that is usually needed for the dams, because if you build a dam, it's gonna take a heavy cost, since you need to survey the area, you need to look at the soil, what's in there, what's the debit, and calculate all that to produce good energy, to produce like efficient energy. But if you use AI and IoT to speed up the process, we could actually build more dams into and integrate it into Indonesia's many canals.
Okay, thank you. That's all from me. Okay, I would like to continue the question from him. Uh, Leji, uh, the the system operates and voltages. Yeah, what technology that you think you can it helps the increase the safety and efficiency? How many kilowatts that you this distance of power source?
Thank you for the question, sir. But as this is in Siak, and Siak is not really near here, and since it's not been heavily researched, there's no debit. Since if you want to calculate the dam, you first need the mass density of water, the height of the dam, or commonly known as the head, and also the power of gravity. That's why since we don't also times by the debit, but since we didn't know the debit, we don't really know the estimates. But since we're going to make it into like a pretty high dam, it's usually like probably more than 10 megawatts.
Yeah,
That's the
that means
conservative.
it's quite or very high currents, yeah, very high voltages, yeah. So, what is the technology that can help to reduce or increase the safety and reduce the inefficiency?
Okay, so firstly, thank you for the question, sir. So, in order to answer the question, depending on the safety and how to reduce the efficiency of the dam, um, first thing we can technically use GPS to look at where the water flow is going to go in and go out, and we can also implement some safety measures in according to uh, maybe build up a like sort of safety net for all of the people that on the surrounding area, and we can also use like as you've mentioned before like AI and IoT and all of that to reduce the efficiency by putting up a simulation to sort of like look at how the dam operates and how much energy that they are going to produce, and maybe look at a few of the setbacks that could potentially lead up to to future inefficiency.
Yeah, you can AI to learn how the all the system works and capturing the data is when it operates the 24/7 is the mass of data that you can analyze, yeah, and to help your system, your turbine, your generator works, yeah, and improve it, yeah. Who artists could strategically be willing to invest in this project, considering that renewable energy helps to reduce carbon emissions.
Thank you for your question, sir. Since this is renewable energy, after all, the party that will be most likely to invest in it is none other than our government, since almost every renewable energy is already part of the government. That's why there's like PLN and other stuff. Pump. Also, most of the programs that Indonesia is currently running is actually to make the world a better place. That's why they're also trying to reduce carbon emission. That's why, like in Mauritius, in Bali, they already made like another also a ROR hydropower plant to facilitate the surrounding school, since it was a very remote school. That's why they need to build a dam, so it's more efficient to just give it to them.
Any kind in specific industry that you think uh, willing to invest in this? Business organization?
Okay, thank you for the question, sir. From the many industries that's around the world, we have chosen some. One of them is the housing industry. Yes, nowadays houses still use energy or electric that is given by PLN, and we have to pay our PLN for every month, right? So, as we created more advancements in this technology, such as ROR, we can create a better electricity, so we can give or supply the houses in Indonesia with electricity a lot more, because in Indonesia right now there's still a lot of houses that is not have electricity. The industry is housing, sir. And it's the housing industry.
Some area is excessive, doesn't need anymore. It's the problem of distribution.
Thank you for your question, sir. Now, because this is ROR, and like I said, there are many different types of ROR. There are some RORs that are actually really small and can solve the distribution power because they could just generate it in like a specific place. So that's why they could make like an off-grid power plants to just supply the local village or the local city, small city. So they all of Indonesia could get and electricity and energy for quite a cheap price without much problems.
To my last, the initial investment is quite high, right? Or we can say very high. What are your thoughts about the political constraints regarding the initiation of this project? Since the massive amount of capital investment need also assurance for the long term from government. Okay, so to answer your question, firstly, thank you for the question, sir. So, to solve the 17 UN problems, for example, like even United Nations already trying to solve the 17 UN problems. Firstly, it's to solve the energy problem by implementing hydropower. So there has already been like a couple legislations regarding this. So to get the other people's support, I think even United Nations already support all of the things that are related to all of the things that are trying to solve this energy problem.
I can also add in this that we can create campaigns to move the people of Indonesia to realize the problem that we are facing right now, to lead us to a better future together, not just some people that is working together towards a better future, but all of Indonesia together. We as one will try our best to go to a better future with this.
I want to add a little more, and to make sure all of the people trust in our innovative ideas. We want to make our whole ideas, because with the high initial cost, we want to make sure the people will get the benefit as they already paid. So we want to make sure our progress, our machine is transparent. So we can see all Yeah, so they can see the progress, they can see the benefit to them. That even though the initial cost is very high, super high, but they will get more than that. The advantages, the overflowing energy, and so many other positive things that will come to them. That's it from us.
Thank you.
Okay, very good work. Yeah, I saw that you were discussing before you answer a question. By the way, do you know where Liwangi River is? Because you mentioned it, you couldn't find any Chiliwangi River internet. Three, yeah.
To answer your question, sir, the Chiliwangi River is located in Cengkareng. Actually, all you need to do is just go to Google and search for Sungai Chiliwangi. There is usually already a lot of information about it. There's even the Wikipedia page for it if you also want to see it.
Yeah, actually, I just typed and I couldn't find any Chiliwangi. Yeah, but there is Ciliwung River. Yeah, and it is in Jakarta. Do you mean Ciliwung?
No, I'm pretty sure it's like a difference in local names since in my phones, most people call it Chiliwangi, but some people also call it Chili Wong.
Is it the same?
Yeah, I'm pretty sure so.
Okay. Chiliwangi. Yeah. Okay. Did you conduct the research on site or just literature review? You mentioned in chapter 3 that you will implement uh, the research to two canals, Siak River and Chiliwangi River, right? Yeah. Have you visited Siak River in Riau?
To answer the question, no, because the Siak is last time I checked, I'm pretty sure it's in Sumatra and
Yeah,
it's
Sumatra.
very far. What the research paper meant is that both of those canals could be great candidates to put the system in.
Okay. I would like to ask more. Yeah. Uh, installing hydropower system in canals can obstruct some nature of aqua life, because the Siak River is utilized by the people to uh, water consumption, for washing the clothes, yeah, for drinking and etc. The turbine or material characteristic of the hydro can obstruct the life of the habitat there. So how do you cope with this issue? You mentioned that you want to try to see, yeah. So there will be another consequences. Usually come out with a protest by the people living there. How do you deal with the issue?
Okay, thank you so much, sir, for the question. So we have come up with two solutions to this. The first one is we have to make sure the people around the Chiak River have already known about the project. We are going to inform them about the project, and not only that, we are going to give them other benefits to compensate for the building of the river or for the dam, my bad, and to compensate them so they can maybe transport them to another place or maybe give them a solution of alternative solution to their showering or cleaning clothes and others. And the other one is
We could also just build it in the end of the river, since the end of the river is mostly just to since the end of the river. If you put it on the end of the river, the area before the river, of course, will rise. So they will probably get. It will be easier for them to actually use the water, but it can also generate some power. So that is also another solution to the problem.
Okay. Question from uh, what is your main contribution of the research? This is to create a design, a hydropower system, hydraulic system. Do you intend to design that and give that to the government? What your intention?
okay. Thank you, sir, for the question. We have two main contribution. The first one is we're going to spread awareness to this problem as our research is could our research could inspire other people or other young Indonesian students to build or to think about this problem and to know about this problem. As we are still included as high schoolers, a lot of people could look up to us or maybe get inspired from our work to maybe create their own work and start their own research towards this problem. And the other one is
Other than that, we could also try giving it to like a civil engineer to ask for their opinion and how this could actually be made and if it's possible or not. Since after this, I'm also gonna try to study in civil engineering. I'm also gonna try asking like how it's gonna work and maybe if it's possible or not. And maybe I could also just give the design to the professor to ask if it's possible or not. And if it's possible, I could maybe just help design it and give it to the government to see their opinions.
Thank you.
Thank you, sir.
Tes.
Tes 1.
Hello everyone, we are from SMA Nasional Plus BPK Penabur Bogor,
Tes 1, 2.
and today we will present to you about the development of water purification. Beforehand, I will introduce myself and my team. My name is Delin.
My name is Kezia.
My name is Vincent.
And my name is Lucky.
As we know, access to clean water is essential for health, but in Indonesia, many still struggles to access to clean water. Indonesia also faces many challenges as rivers and lakes often get contaminated by industrial and agricultural runoff. World Health Organization identifies that contamination of water as a significant public health concern. This lack of clean water, especially in rural areas and those who is lower socioeconomic status, exposes to millions of harmful bacteria such as Salmonella typhi and Vibrio cholera, causing typhoid and also cholera. So our goal first is to explore technologies and innovations to improve the water purification systems in Indonesia by highlighting affordable and energy efficient solutions such as IoT and AI-based systems. So the purification process keep on processing even in the areas with limited power access. According to United Nations, around 2.4 billion people lack access to clean water, and according to Directorate General of Pollutions and Environmental Damage Control, 59% of the rivers in Indonesia are heavily polluted. So therefore, this case is really serious and needed to be solved fastly. And it is also make the waterborne disease increase every year. The research method we use is qualitative literature review, which involves analyzing secondary data such as journals, articles, scientific research, and other information from the internet that aims to focus on addressing the SDG 11.
Okay, so now to address that issue, we as a team have come up with a solution. We were thinking about constructing a solar panel based water purification. The idea is that the solar panel will act as a power source to the water purification system. However, beforehand, we need to understand that water purification can be achieved through various methods. In this case, we will be using the activated carbon filter method, which is an economically viable and simple option, which helps us to target rural and low-income areas. Although activated carbon filter is useful, it still has some weaknesses. It is incapable to filter all contaminants. And hence, we need to combine it with other water filtering method. In this case, we will be using the reverse osmosis method. So reverse osmosis utilizes a membrane or a semi-permeable barrier. It works by pressuring the more concentrated solution through the membrane towards the less concentrated solution while also blocking contaminants. Last, we can also add UV disinfection to kill any bacteria or viruses. It is also important to note that this idea had already existed beforehand.
So now we need to add features to cover up those limitations because the current solar panel-based water purification still has some limitations to it. These are the three additional attributes that can further enhance the water purification's performance. First, we are going to implement the IoT or Internet of Things to the whole water purification system. We will mainly be utilizing sensors that can detect pH levels and turbidity levels of the water. We will be taking advantage of, for example, a system like Arduino to create those sensors. So for example, if we want to create a pH level detecting sensor, we can use Arduino components such as maybe the Arduino Uno board or the breadboard or the LCD display or maybe some kind of electrode solution. And then we're going to implement the artificial intelligence or AI-based energy management system. Now this functions to reduce human error in the process while also encouraging efficient energy usage because this AI will be designed by us or we intend it for it to manage energy usage based on the contamination level of water. And then last, to ensure operation and functioning during cloudy days or nights, a hybrid energy source with solar power as the primary source will be useful. Because so on days that the sun does not shine as frequently, a backup energy source will ensure the functioning and operation of the water purification system.
So now let's dive into some comparable water purification innovations, such as the live straw community. The live straw community uses these advanced small membranes that is around 0.2 microns that makes that is able to remove the bacteria or the other pathogens that is available on the water. The live straw also provides affordable and clean water to rural areas or small areas using cost-effective and affordable and sustainable technology. Second, we have the solar-powered desalination system. The solar-powered desalination system uses solar power to remove salt and other impurities that is in of the water. The desalination system is a crucial role in providing fresh water in coastal areas, much more like Indonesia, where most of the water is salt water. This relates to our project's focus, where it uses renewable energy and it also purifies the water. Third, we have Eureka Forbes Dr. Aquaguard that incorporated IoT technology, allowing users to monitor and manage the system using via the app. This makes it easier to track and monitor the water quality and also to maintenance it remotely. Another exciting innovation is the IBM Watson's supercomputer or AI management system. It arranges the data from water systems or from the IoT sensors and it provides insights. It uses a data-driven system, so it making it ensure what efficient water management.
So, in conclusion, the water purification system that we have developed has addresses the critical and also ongoing global issue regarding the need of a clean and sustainable water, which is still again a big problem in many areas in the world with limited access to clean water, which includes some parts of Indonesia. Therefore, we have also developed a water purification system that are designed to overcome the challenges and the limitations of this current water purification technology. By harnessing renewable energy sources such as the solar power and also integrating various technologies into it, such as the Internet of Things or the IoT sensors, to be able to obtaining a data from the water quality through a real-time monitoring process and using artificial intelligence to create an AI-based energy management system to optimize energy usage, we aim in creating a system that will not only purifies water effectively, but does so efficiently and will continuously for a longer period of time. Moreover, we also ensure that our system will not only reduce
will not only reduce the overall cost needed for the operation, but are able to stay functional even in challenging conditions. This will furthermore help our system to be more accessible and also affordable to many people all around the world.
So, as a final touch, the sensors will be integrated to the software and mobile applications so that the exchange of the data will be much easier and more convenient.
So the usage and combinations of these technologies together will ensure that the solutions provided will be adaptable, applicable, and also highly impactful for communities and people in need of clean water. And please remember that only by working together, we can all help bring changes to the world and the people in need. That is all for our presentation from us, BPK Penawar Bogor. Thank you for your attention.
Bor ya. Once again.
Okay, so the method we're going to be using is something that is actually regularly known in water filtering field, which is reverse osmosis. So the reverse osmosis water filtration system consists of 4 stages to be exact, or maybe 3. So first, when the water goes into the system, it goes into the pre-filtration. It goes through sediment filtration and carbon filtration, which functions to remove dirt, debris, and then maybe chlorine to remove any bad odors or foul odors. And then for the second stage, it will go under the reverse osmosis process, where on the upper image, there is an explanation on how reverse osmosis like filters the water. So, for example, if we have seawater and then we have fresh water on the side, we're going to put a reverse osmosis membrane. Now, reverse osmosis functions by pressuring the more concentrated solution, which is the seawater, because they contain salt molecules as well. Now, by pressuring that solution, the liquid will go through the membrane towards the less concentrated solution, which is the fresh water, but the membrane does not allow the salt to be passed through, so that makes it much more cleaner. And then the sediment filtration sorry. And then after filtering from the reverse osmosis, it will be filtered towards it will be transported to the storage tank or faucet. However, if it is wanted to be, like if we want to use it, if we want to transport it to a faucet, we need to have a post filtration, which is a post carbon filtration, to ensure that the water is clean, it doesn't have any bad taste, or it doesn't have any foul odors. Yes, because in Indonesia, seawater is the most available. Okay, so we might not have like the full answer to that, but this is related to the overall system where there is activated carbon filtration, which functions to like remove chlorine, which where chlorine makes the water more acidic, and then we also have a pH sensor, which is an additional feature. So uh, if we currently don't have the solution to make the water less acidic, to make the water less threatening, that can cause our reverse osmosis system to be corrosive, we're going to first carefully maybe choose the source of water by detecting the pH level first. We're going to detect the acidity of the water by using our sensor.
Total ya. Ya. Eh, eh,
So, as we know, the artificial intelligence or AI has always been helping humans also to perform various tasks. And one of them is to detect and also analyze data. And it's also the same in this case, which we will be using the artificial intelligence to collect the data regarding the level of the contamination of the water, as it is also connected to the sensors, and it will also help in collecting these data of the level of the contamination of the water. Then we can use it in order to help in pushing the efficient energy usage. Like, for example, when it detects that the level of the contamination of the water is high, then it can set the system to uses more energy because the level of the contamination of the water is still high. So in short, it will just like adjust to the level of the contamination of the water. So therefore, the energy will be used more efficiently.
This AI also uses a data-driven system which analyzes the water using the IoTs or the sensors that we have. Similar to what Kezia said, uh, it is based on the contamination of the water.
So it contributes to the reducing of the usage of the energy in the systems that operates by the equipment of the water purification, such as pumps and valves. So it reduces the footprints of water purification systems and therefore reduce the energy.
Okay, that's next just please. Okay, thank you. Parameters from drinking water.
Okay, sorry for the wait. From our research, when we were like working to find out what defines a clean water, it is stated that clean water is an alternative natural resource that contains great quality and could be used for human activities, including drinking. So maybe this is more to the drinking side, but in general, cl- clean water has characteristics of first, it must be colorless, it has no taste, and then it must not feel sticky. Probably when we after use it, because sometimes when we use water to clean our hands, sometimes our hands feel sticky, and then it has no smell. It has a neutral pH level of 7. It is clear of harmful microorganisms. It has no dust, sand, or any type of sediment.
So for us, it's good to invest in the solar panel based water purification because first solar panel convert the energy from the sun, which Indonesia is hot and humid as we know. And then the solar panel can also uh, keep the energy as a backup for emergencies, and also it is for a continuous or for a long time. So it is a good invest as a clean water, as the clean water also expensive.
Okay, so maybe all the equipment, maybe all the costs could be quite costly, could be expensive, but personally, we think that it is beneficial to invest because, as we know, clean water is something that is rare. It's hard to find in Indonesia, especially where access to clean water is very limited. So if we, for example, is able to produce clean water, it is more useful in the long term. For example, if we invest in solar panel based water purification, it is better for the long term, even though it is like more expensive compared to maybe probably electricity generator that is based on like based on fossil fuels, where fossil fuels is something that is rare, and because it is rare, of course the price will skyrocket. And then the additional features will ensure that the clean water produced is more likely to be clean. Like it's more likely to be clean than the other water purification. People will be more will trust this water compared to this because of the many features it has. Although it is costly, it could also be invested for long term, and then it could also be used as a business because we can sell these clean water in mass amount. We can sell this to many people. We can then brand ourselves because we have many features. We can make our name more trusted, and then we can try to make a business concept according to that.
Okay, let me confirm first. Are you planning to combining all this technology, or are you saying that one by one of this system is cost justified? Let's say, you know, for the water treatment, seawater already there, also solar panel distillation already there, and itself justify. But are you planning to combining all of these technologies or not?
So, in our opinion, it will be better if we gather all of it all at once rather than do it one by one, since one by one, we feel like it won't be as effective as gathering it all of it in one go. Sorry.
So as we mean is all the system is still separated, but it is combined in one water purification system.
So we hold this water purification as the main focus, and then like the solar panel, artificial intelligence, IoT are all additional features for this water purification. So the water purification is more like utilizing all of them to its benefit. So the water purification can be more trusted, clearer, and can be more accurate. So in our opinion, we think that we are combining these, we are adding, not combining, probably adding features to the water purification.
Yeah. Okay. I hope this will go on. Yeah. Civic, you may. Strategy.
So, from our brief discussion, there are three main challenges. First, uh, the cost. The cost might be expensive. It might be even inaccessible for them. Second, rural and low-income areas may not be accustomed to new technologies due to probably the challenges they also face. Okay, sorry, there's only two.
And however, the benefit of our water purification is first, it makes a community resilience, which means they adapt to the environmental challenges, and also the better usage of available water, which also leads to the better agriculture because it also uses this system.
And furthermore, also please note that one of the features of our system is also using a renewable energy. And in this case, this will also provide a benefit as also, as we know, Indonesia also pushes energy transition lately from the fossil fuels to renewable energy. And using this system on such rural areas or low income areas will also help in prioritizing and ensuring that this energy transition is also equal to many areas in Indonesia.
This could also like cover the cost because if the trend is going like that for the transition, then we can maybe interest more investors or businessmen that are willing to invest and may probably make our concept a business. That could help for our financial support and designing of the water purification system.
Yeah, you mentioned also about business. Yeah, yeah. How long do you think that if the three of us want to invest on your system, how long will it break even? How will our investment will be break even? Balik modal. Yeah.
So, based on our discussion, it might take a long time because rural areas and communities usually needs to adapt, especially in new technologies involved. So, therefore,
So from our brief discussion, we have never discussed about this business actually. So we were thinking about probably when investors invest in our production, they only invest on the machine and on the maintenance because we are using renewable energy as a source of electricity. Production costs would be largely cut off, and then maintenance will probably be the changing for carbon filters, change for 1 year probably, and then we were thinking that maybe if we have these water, this water that results from a mass production, we can also sell it, and then we can also sell this design. Maybe we can compress it into a smaller product. For example, the livestock community, which has been presented by him, is like a convenient water filtering tool that you can bring anywhere. It can, when we want to drink water from an a dirty source, we can use that as a portable water filtering system. So if we sell the design, and then if we could also sell tons of water. Maybe we can sell to rural and low income areas with maybe some percentage lower than the usual rate, which makes them more able. We can also sell this design to people, yeah, where people probably is that are more able in his life, their life, like they are more sufficiently financially sufficient. Probably that's for our business model that we've been thinking from like this short discussion. Sorry.
Us to submit a paper, right?
Sorry. Gimana kalau gini? Kita masing-masing kata sampai gimana saya discuss. Kita masing-masing kasih apa bisa AI, bisa pakai AI. Masing-masing aja ngomong. Kita kasih. Gue dulu ya. So the paper was written by all four of us, right? So there's section that are worked by Delin, by Kezia, by me, or by Luki. So we encourage each other to check the text. We encourage to check it on the plagiarism checker, and then if there's a plagiarism detected, we're gonna try to paraphrase those words. We're going to try use our own words to explain the materials that we have gained from resources on the internet.
So based on what I do, so we divided parts for writing the research paper. And so what I do is first research. I usually read articles and journals, but I do not do copy paste. So therefore, I try to find all the resources and paraphrase it if I found anything important. And I also add some data, but I also add the sources. For example, I write based on United Nations or other else.
I think I'm just gonna add from what Winchan and Delin has also said. I think I pretty much do a similar thing. So basically, I do research, and of course, I mainly prioritize searching from the websites where the data will be entirely accurate. And then another step that is also important is to put the sources into the references list.
Also, for me, there's the Lystra, which has been popular in the internet for quite some time in the early 20s or after that. So I got this idea mostly from the internet or from YouTube that I've watched since the pandemic. There's also the, if I'm not wrong, the IBM Watson's supercomputer that have been in TV before. So I got my idea from that too.
So to close it, we are sure that we do not encourage any plagiarism or maybe utilizing AI so much because we have some kind of like pride in ourselves on what we do. If we do something that is not based on our hard work, then we cannot claim that it's our hard work. There's no like pride in there. So we as a team is sure.
Answer, and that's congratulations and well done.
Thank you, Pak.